All right, we're going to continue the notes from yesterday. I'm actually going to restart the end behavior example. After viewing the recording, it seemed like the end of the last recording was a little bit off in the sound. It was a little gritty, so we're going to redo this example and then continue on with the notes. This is 3.5 part 2. Describe the end behavior of negative 2x cubed. Okay, we need a picture to understand what is happening out at the ends. Okay, so graphically, we can go right to the calculator and put it in and take a look at what it looks like. Negative 2x to the third. Zoom 6. And we can zoom out. We can change the window. We'll make the window a little bit higher and lower. So I'm going to go like negative 50 to 50 on the Y, min, and max. Doesn't change much. What's happening to Y when x goes way left? So limit of fx as x approaches negative infinity. So on the calculator, where's the graph going? If we start in the middle, we move to the left. Okay, the graph's going up to positive infinity. Follow my cursor on the calculator. As we move out to the right, where's the graph going? The graph is going down to negative infinity. So we want to know what's happening to y. Are the y values increasing? Are the y values decreasing? Or are they flattening out to a specific number? So as we go left, again, following my cursor from the origin out to the left, the y values are increasing to positive infinity. Start the origin, we go to the right, the graph drops, y values are decreasing to negative infinity. That's all you need to do. That's end behavior. At this point in time, that's the best we can do. Get the calculus. Now we're talking, we can do a little bit more with end behavior. So how about x squared? Now x squared is one we should know. Shouldn't have to think about that one. Vertex at the origin, it's a parabola pointing up. So let's draw right here. As I'm going out to the left, as x is approaching negative infinity, where's the graph going? The graph is going up, 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 up. So the y values are increasing forever to positive infinity. So the limit of f of x as x approaches negative infinity, what's happening to the y values when x goes way left? Well, they're increasing to positive infinity. The same thing happens from when we go to the right. So I start at the origin, I'm going out to the right. X is approaching positive infinity. Where's the graph going? The graph is increasing to positive infinity. So the limit of f of x as x approaches positive infinity also goes up to positive infinity. So we're simply asking, are the y values going to increase forever, decrease forever, or possibly approach a number? That's it for end behavior. All right, let's take a look at the next page. Increasing, decreasing. Basically, what's happening to the graph when you read it from left to right, or when you're looking at it from left to right? Is the graph going up? Is the graph going down? This is best going to be described by looking at the example. So, the question is, determine the intervals of increasing and decreasing for f of x. Let's rewrite this because this is probably not in the best form. We just finished up with transformations. we should be able to get a pretty good idea of what this graph looks like by considering transformations. The original would be y equals x squared. At the origin, pointing up, a parabola. The negative causes a reflection across the x-axis. We're going to go right 5 and up 3. So, right 5, up 3, it's going to now be pointing down. So that's just a basic sketch. That's what I think it's going to look like. We can always confirm it with our calculator. So we have negative x minus 5 squared plus 3. Zoom 6. That looks very similar. Okay. So the question is now, from left to right, starting from the left, a little different than the end behavior. End behavior, we start at the origin and went out. This, we start at the left. So from the left, we're going to trace the graph. So I'm going to go to the graph. Okay, the closest part to the left, and I'm going to start drawing arrows from left to right. Now I'm going from left to right. As I move from left to right, the graph is increasing. It's going up, as you can see with the red line. So we are increasing. How? Well, where exactly is the increasing and decreasing stopping? To me, it looks like at about 5. So everything left of 5 is increasing. So x less than 5. Now, to the right of 5 is decreasing. So x greater than 5. We do not include the actual point where it switches from increasing and decreasing. We're going to talk about that in the next section, and that's basically called a maximum. Maximums are not increasing or decreasing. They are a point where it switches from increasing and decreasing. So we do not include that. So it's always going to be less than or greater than something. We're talking about increasing and decreasing. So there's 2 intervals. Part B. Let's see if we can sketch this one. Start with the absolute value of x. It's a v at the origin. The 1/2 is a vertical compression by half, so it's going to smush it. The plus 3 makes it go left 3, down 5. This is what the negative 5 does. So left 3, down 5, and it's going to look smushed. So the critical point looks like it's occurring at 3. Okay. I'm going to read this graph from left to right. Again, if you don't know what the graph looks like, okay, we can put it into the calculator. 1/2 or 0.5 absolute value. So 1/2 math num absolute value of x plus 3 minus 5. Zoom 6. And that looks very much like what I have drawn. So from left to right, I'm going to start reading the graph, or I'm going to start drawing arrows. Okay, so from left to right, I'm drawing arrows. Where do they point? Well, the red ones are pointing down, so that's decreasing. From what to what? Well, basically anything left of negative 3 is going to be decreasing. So x is less than negative 3. And then it increases. Anything to the right, or anything greater than negative 3, is increasing. That's it. Just need to draw the arrows and determine whether they're pointing down or up. If they're pointing down, it's decreasing. If it's pointing up, it's increasing. And always remember the critical point. In this case, it's a minimum. The critical point is never included, so it's always less than or greater than. I have one more. Part C. Now, 2x cubed plus 3x squared minus 12x plus 3 is something I don't expect you to know right off the top of your head. If we were talking about end behavior, I think you can figure that out, because end behavior is controlled by the largest power, in this case x cubed. So we could actually draw a sketch of what we think it's going to look like, but it could have some other bumps in it. Calculus will allow us to find those bumps by using what's called derivatives. We're not there yet. So the best we can do at this point is graph it using our calculator. 2x to the third plus 3x squared minus 12x plus 3. 2, 6. Okay, now we can't see all of the graph. The top of the graph is slightly cut off. So I need to change the window. I need to make the Y max higher. So I'm going to go Y max, let's try 50. Let's see what that looks like. So we hit graph. That looks pretty good. I have a pretty good idea of what this looks like now. So, where's my critical points? Where is the peaks and the valleys? Looks like to me at -2 we have a peak, and at 1 we have a valley. So this is just a sketch, but that's what I think the graph looks like. So let's start drawing arrows from left to right. Okay, so what's happening? From left to right. Looks like it's increasing. Anything less than -2 looks like it's increasing. Now I'm not going to close this off yet because I see another increasing part. I'll come back to that. Let's take care of the decreasing. So from -2, it looks like 1. Then from 1, or I should say greater than 1, it is increasing again. So we have 2 intervals of increasing, 1 interval of decreasing. And if we look at the calculator, we can see that graph is going up, stopping, going down, stopping, and then going up. Increase, decrease, increase. Okay, that's all I have for that. That's the end of 3.5. We'll start with 3.6 next lesson.